Yes, I'm Valentin. I work at Codethink, and I'm a contributor for Freedesktop SDK. And recently at Codethink, we have been looking at porting Freedesktop SDK to RISC-V, and here is a small report of where we are at. So first, background: what is Freedesktop SDK? This is the main Flatpak runtime. So what are we talking about runtime? Is that Flatpak is like a container system for desktop applications, and for every container you need to have a base system where you have the shared libraries that are needed for the application. So this is what we provide. We are also the base to make the runtimes, the Flatpak runtime for GNOME and KDE. And there are also other applications other things that we do with Freedesktop SDK, including making bootable images for GNOME OS. At least we make the best so that we can make GNOME OS. Freedesktop SDK is not based on any distribution. It's all built from scratch, and this is built with Buildstream. Just to be clear, Freedesktop SDK is a part of Freedesktop, but what is in Freedesktop SDK is not necessarily Freedesktop, so there is no endorsement from Freedesktop when there is something in Freedesktop SDK. RISC-V, it's a instruction set architecture for CPU, and the specification of this is open source. So this is very nice that we are getting there where the hardware start to be open source. That doesn't mean that the hardware that we will have as RISC-V is necessarily open source. There would be bits that are not, but at least the specification of how the CPU should work is. There are RISC-V. There are multiple things. It can be 32, 64, 128 bits. So it's different processors. It's a set of different processors, and for each there is extensions for multiple different applications. For example, you might want to make a RISC-V microcontroller for very small embedded things, but you can also maybe make a processor for a supercomputer. So it covers lots of applications that need a microprocessor. But that also includes desktop, so we have to expect that we will see some desktop computer at some point that will use RISC-V. I hope we will get there. It's the right time for us, so we want to get Freedesktop SDK to RISC-V because we know that it will be used, and it's the right time for us because first all the main parts of the free software have been ported to RISC-V, and this has started in things started to be merged upstream in 2017 with Emulation and GCC, and then later we got everything we needed. And recently, the last big piece for us, Freedesktop SDK, was merged, which was Go. It's not part of the Flatpak runtime, but we still depend on it for other things, like, for example, the GNOME OS things. So pieces are here. And also the second thing is that there is some experimental hardware that is going to be released soon that will be able to have some okay experience with desktop application. So it's nice to be able to test as early as possible. So to build it, first we targeted only one kind of RISC, so the 64 with the main extensions that are expected to be in desktop. So this is a default actually for the 64-bit RISC-V for GCC. The development has not been that difficult because, first of all, Freedesktop SDK bootstrap part. So when we build the minimal system that has, for example, GCC, binutils, glibc, bash, mech, and things like that, this part can be cross-compiled. so we can make a port to new systems as long as we have all the support in the toolchain. But the rest needs to build on the target architecture, because there are so many projects that are very difficult to cross-compile, and we need to have so many patches to deal with it. So we don't cross-compile the rest. That means that we need hardware, but we don't have hardware yet in Freedesktop SDK, or at least we don't have hardware that is capable of building it, because we need a lot of memory. So what we have done is using QEMU for emulation. In QEMU, there's two kind of emulation. There's the system emulation, where you boot an OS, but there is also the user emulation, where you can just say, I have a binary that is for a different architecture, but I want to run it on this current kernel that I'm running, which is another architecture, and it will translate the system calls to the current architecture. So you can just run the binary in your system. So we went for this user mode, where we just execute the binary, because it was better for us. First, we don't have to depend on a distribution that was built for RISC-V, so we don't have to deal with this. And we can build everything at once as we start to build something that to the bootstrap that does cross compiling, and then after we just switch to building on RISC-V, and everything happens on the same machine. It's also a bit faster, but the other thing is that we found that it hangs sometimes, and the main problem was cargo from Rust that was hanging. We have found that with just a simple environment variable, we could just work around this. Hopefully, one day we will be able to fix the bug in QEMU, but it's a very difficult bug to fix, but that works. So most of the upstream things that were concerned by supporting RISC-V, that as assembly, things like that, they were already supporting RISC-V, and the rest was just minor fixes. So we had lots of small fixes and lots of updates to make sure that we had the last upstream version. There are a few things that we didn't get to get, and two were mostly for debugging. So Valgrind, which is a very nice tool, but it's not yet available for RISC-V. Lib unwind, in practice, it can be used for a lot of different applications, but well, in theory, it can be used for a lot of applications, but in practice, it's been used only for debugging, and we can disable this, so we can provide a Freedesktop SDK without lib unwind, and it's fine. Another thing is that the per-compatible regular expressions don't have JIT compiler, so they might be a bit slower, but this is a minor thing. We have also looked at the GNOME SDK, and we have not found anything very special there, so everything should be there. What if you want to build your Flatpak application for RISC-V? Well, it's possible. You probably need to have some technical background, but it will be very quick. The first thing you will need is you need to have QEMU user on your machine, and you will need for RISC-V, and you will need to set up the BNF-empty MISC so you can run directly the QEMU when you call any binary that is for RISC-V. The second thing is that you will have to build Freedesktop SDK. For the moment, the Freedesktop SDK runtimes for RISC-V are not published yet, so you will have to build it on your own. Then after you will get a repo, you will have to install it on your computer. And then after, you will probably, depending if you use Rust, for example, you will probably have to define the same environment variable that we used in your manifest. And then after, you just have to call Flatpak builder and just say you want the right architecture, and then it will build. And then after, you can test. Let's see. So a few months ago, we tested that. We wanted to be sure that we can build a Flatpak application for RISC-V, and this is actually running in the virtual machine. The result, this was super tux cart that we took from FlatHub, and we just adapted a few things, and we build it with the instruction I gave before, and this is running. By the way, what you see around is just a bootable test image that we have in Freedesktop SDK that get a bootable image that has a Weston and Flatpak, so we can test Flatpak. By the way, Flatpak works in RISC-V. There is nothing special about this. What now? We need to publish the Freedesktop SDK for RISC-V. It will be published in August. There will be a new release, and that would be just for testing. We don't expect that this will be something really used, and this will not be on Flatpak. You would have to download it from the Freedesktop SDK Flatpak repository. We need to get, we hope to get hardware soon that is capable of doing to build in the CI. So to have builder, so you will stop using QEMU. This is a temporary thing. We also need to prepare the builder images, because the way the CI works for Freedesktop SDK is that all Docker images that we use are based on Freedesktop SDK. So we really do dogfooding, and we just use Freedesktop SDK everywhere. So we will have to take care of that, but it's not very much difficult. We know it will probably work with, we have all the pieces there. And well, the question is now, when will we have hardware for Flatpak that is capable of building a RISC-V? That's a question that I don't have the answer. The work that was done on this project was done by a few engineers at Codethink. A lot of commits came from James, so thank you for him. And Freedesktop SDK is not a Codethink project. We try to invest time in it and getting it there, but there is an independent there. So if you're, we need a community there, and we need more contributors. If you are interested, for example, in contributing in publishing the snap for a Freedesktop SDK, we are looking for people who can do that in the community. Come on the RC channel. For Codethink, we are hiring these days, so there's this URL. You can follow that, and all the information is there if you want to work at Codethink. This is a short talk because we didn't know if we would have so much material to talk about, but there is more things that are coming at Guadec, so see you there. Are there any questions? I will go to the share notes. Yeah. Yes, so the first was when it will be available. The build will be for testing in August. You can already, it's already merged. So if you check out the master and you build that, you get it, and it's one command line make export with setting the arch to the right architecture, and it will just make your repository. Or it's what's in it for Codethink? It's so we use this tool called Buildstream, which is also independent, is an Apache project. But we provide consultancy at Codethink, and one of the things that we provide is consultancy on building things and including Buildstream. So Freedesktop SDK is a very good case for testing Buildstream and making sure that it works, and yeah, that's what it is. But also Buildstream is also independent, but it's just we need tools to provide consultancy on. It just if we go to customer, we need to have some solution on things that yeah, that's it. Okay, how does RISC-V relate to ARM, which is currently popular? I think so I don't know much of the assembly part. I mean, how the technical part of of ARM, I've noticed there is some similarity of how things are of the design. They are both RISC kind of processors, and they have some similarities in some of the designs. I think they're in the addressing, for example, and things like that. But I don't know the details. But the open source of the specification is a good thing, because the ARM is a company, and to be able to make an ARM processor, if you want to make a system on a chip, right? With some pieces, and it has the ARM core in it, you need to pay ARM, whereas RISC-V, you can choose with either you develop yourself the core, or you find someone else will develop a RISC-V core that and you can change any time of your design the core, and you stay on the same instruction set, so your binaries stay compatible. So I think I think that's the main important thing. And also I know that, for example, for university, it's better to work on RISC-V than ARM for the issue of licensing with ARM.